Morning, good morning, pleasant music. Good morning. Chalo, so we are going to start and we will be solving few questions, around 25 questions, BARC related questions from the basic thermodynamics part, but we have divided the entire thermodynamics into two parts, okay? So we will talk about first law, zeroth law, basic concept, all these things we will cover today. Then the next part, which is second law, entropy, available energy, and all these things we will cover in the next section, which is tomorrow. Okay, chalo. So in this session, we will be talking about BARC level questions, not just BARC level. Basically, it will cover any PSU level questions. Okay, chalo. Before we start, let me introduce myself. So I have 6+ years of teaching experience. I have taught for GATE, ESC, AE, and other PSUs as well. MTech I have done from IIT Kharagpur. MSc I have also done from Politecnico di Milano. और 3.5 years का रिसर्च एंड इंडस्ट्री एक्सपीरियंस है और कुछ रिसर्च पब्लिकेशंस भी हैं. एंड एज यू ऑल नो माय एरिया ऑफ एक्सपर्टीज इज बेसिक एंड अप्लाइड थर्मोडायनेमिक्स एंड हीट ट्रांसफर. ठीक है, चलो. नाउ गाइज, ऑन द ऐप there is a live workshop of preparation strategy to crack GATE 2025 in one shot by Anil Prasad sir, and it is scheduled on 13th March. So if you are targeting GATE 2025, then you should attend this workshop. And if you want to join Vision batch, then you can take a scholarship test as well, that is scheduled on 10th of March. Okay, you can take the entire day. Okay, and you can get up to 90% of scholarship if you attend this test. Okay, depending upon how you perform. So as I already mentioned, on 10th March we have scholarship test. You can avail up to 90% scholarship if you want to prepare for GATE 2025, but you are facing some money issues, financial issues, then you can go for this scholarship test. Okay, chalo. If you have not joined, do join my Telegram group, which is Mechanical by Vipin Yadav. Or you can also scan this QR code. Okay, you can search Mechanical by Vipin Yadav, or you can scan this QR code. You can join the Telegram group. ठीक है, चलिए. Let's start with the very first question on thermodynamics. ठीक है, चलिए. So you have to answer these questions before me. Okay, I hope everyone is ready. Yes. Can I start? चलिए. So, which formula is the correct depiction of the slope of adiabatic curve? Slope of adiabatic curve. What is the correct option? A, B, C, D. Adiabatic curve. By when you draw any curve on PV diagram, the slope will be change in pressure by change in volume. Now, the slope for constant pressure is 0. The slope for constant volume is infinite. But what about isothermal and adiabatic? So for isothermal, the slope is minus P by V. And for adiabatic, guys, you have to answer it, not me. It is gamma minus P by V. So what is the answer? What is the answer? It is A. A is the answer. ठीक है, yes, first is the answer. चलो. In an isentropic process, the pressure P of the gas varies with volume. Okay, we have an isentropic process, and it is saying pressure and temperature are related as Pk T phi by 2, like this, where K is a constant. The ratio, what is gamma? This I need to find out. What is gamma? Adiabatic is also called isentropic. Reversible adiabatic is called isentropic, not just adiabatic. Okay, you cannot call adiabatic. Adiabatic is not isentropic. It is not isentropic. Reversible adiabatic is isentropic. Got it? ठीक है, चलो. So I have to find out gamma. Now, how do you find it out? I know that for, okay, this color is not good. For isentropic process, what is the relationship between pressure and temperature? If we talk about isentropic process, what is the relationship between pressure and temperature? So can I write T2 by T1 is equals to P2 by P1 gamma minus 1 by gamma. This is the relationship. So can I also write it as P2 by P1 is equals to T2 by T1 gamma upon gamma minus 1. Gamma upon gamma minus 1. So this can be written as P is equals to K T gamma upon gamma minus 1. So now if I compare my equation A and B, so I can compare gamma upon gamma minus 1 is equals to 5 by 2. Yes, you can do that. Okay, chalo. So gamma, how can I find out? 2 gamma is equals to 5 gamma minus 5. Okay. So now if I write 5 gamma minus 2 gamma is equals to 5, so gamma is equals to 5 by 3. What is the answer? 5 by 3. The answer is 5 by 3. Yes, clear? Guys, please contribute. Clear? Chalo, very good. Let's move on to the next question. This so we have just seen ratio of absolute temperature T2 by T1 at different stages in an adiabatic process is. What is the correct option? Just now we have seen this. T2, how T2 by T1 is related to P2 by P1 for adiabatic. Although this question is not absolutely correct, it should be reversible adiabatic. Okay. So how is it related? How is it related? Gamma minus 1 by gamma, यानी कि ऑप्शन बी. यस, चलो. नहीं भैया. नेक्स्ट क्वेश्चन. A piston, we have a piston of this diameter, यानी कि dia is 0.1 meter. Expands over a stroke L is 0.2 in under constant gas pressure 0.2 meter. Under constant gas pressure, the pressure is 2 into 10 to the power 5 Pascal. Newton per meter square means Pascal. You have to find out the work done by the piston. Work done by the piston. So very simple. Work done for isobaric process is P into change in volume. P into change in volume. Now pressure is given to me already. How can I write change in volume? How can I write change in volume? By area of piston and the distance that it has traveled. So area is pi by 4 into phi square into length. Yes, I think Karan is correct. So the answer you will get is 314.2 joule is the work done in this process. Very good. Very good. Chaliye, let's move on to the next question. Very simple question. If a gas expands suddenly into vacuum, this is what? Expansion against vacuum. Expansion against vacuum through a orifice of large dimension. So let us say I have an orifice here. Here we have gas. Here we have vacuum. So what do you call this process? What do you call this process? Free expansion. Expansion against vacuum. If I open this orifice and gas expands against vacuum, is called as free expansion. Expansion against vacuum is called as free expansion. ठीक है, बहुत बढ़िया. You have to find out work done. Diagram is given, PV diagram is given. Calculate work done. Calculate work done by the PV diagram. Now what do I know? I know that this area is giving me work done. This area is giving me work done. So how can just 1 second, guys. Okay. So how can I calculate work done? How can I calculate work done? Am I audible? Am I visible? Okay. So if I want to find out this area, I have to find out area of this rectangle, area of rectangle and area of triangle. So work done is equals to area of rectangle and area of triangle. Now what is the area of rectangle? Area of rectangle is 2p minus p, height, into width. Width is 2v minus v. Yani कि this is p into v plus. What is the area of triangle? What is the area of triangle? Half base into height. So base is 3v minus 2v and 2p minus p. So this is also half pv. So यानी कि 1 plus 1 by 2 pv, 3 by 2 pv, 1.5 pv, 1.5 pv. Yes, 1.5 pv is the correct answer. This is the correct answer. ठीक है, चलो. The work required for compression in a closed system increases, if work of compression you have to increase, then what is the relationship with N? What is the relationship with N? You can do it two ways. You can write the formula work of compression is equals to P2 V2 minus P1 V1 upon 1 minus N. Either you can do it like this, or you can draw a PV diagram as well. PV diagram. What is the compression quadrant? This is the compression quadrant. And how do you give compression work? This. Area below the curve. Area below the curve. So if I increase N, you see, by N is giving me slope. N is giving me slope. So if this has a lower slope, yani ki lower value of N. But if I increase the slope, then I will have this area. Higher N means higher area below the curve, means higher compression work. You have to give higher compression work. So if N increases, work or area under the curve increases, that means compression work increases. So you can say it like this, or you can say if N is increasing, this whole thing is going to decrease and compression work is also going to increase. Got it? You can see it either way. You can see it either way. Clear? Got it? Chalo. Let's move on to the next question. Clear hai? Is it clear? Quickly, PV diagram is given. Okay, this is PV diagram, pressure volume diagram. I have to tell what is the correct option in the PT diagram. In terms of PT diagram, pressure, temperature, which option is correct? Quickly. And this process, AB is given as isothermal. This is given as isothermal. So very simple concept. If I have to draw a pressure temperature diagram, then I am sure about one thing. What? That BC will be a horizontal line. BC will be a horizontal line, I am very sure. And AB will be a vertical line. Then only temperature will remain constant. And here pressure will remain constant. So if any diagram is satisfying this condition, you can say that is the correct PT diagram. Clear hai? So which option is satisfying this diagram? Which option is satisfying this condition? Option C. You see, B to C is constant pressure and A to B is constant temperature. Here A to B I cannot draw like this. This is wrong. Similarly, A to B is wrong. It is constant pressure. A to B again constant pressure. This is not correct. So these options are not correct. Okay. The only option that is correct is C. Clear hai? Is it clear? चलिए. The ratio of specific heat at constant pressure to the specific heat at constant volume for a triatomic gas. Basically, it is asking, sir, tell me gamma. Tell me gamma for triatomic gas. For triatomic gas. Can you tell me? I hope that you know that for monoatomic gas, if you have a monoatomic gas, then gamma, for example, helium is there, argon is there, gamma is equals to 1.66. If you have a diatomic gas, for example, O2 is there, N2 is there, So here gamma is equals to 1.4 and triatomic, for example, ozone, CO2, gamma is equals to 1.33. 1.33. So what is the right option? What is the right option? D is the right option. ठीक है? क्लियर है? चले आगे, चलिए. Charles law. Charles law state. What does Charles law state? What does Charles law tell you? Relationship between. Charles law gives you the relationship between volume and temperature at constant pressure, and it tells you that volume by temperature is constant. So which option is correct? Which option is correct? D is correct. Very good. Chalo. Read the statement. Zeroth law of thermodynamics states that. Read all the statements and tell me which one is correct. Read all the statements and tell me which option is correct. A, B, C, D. According to Zeroth law, two thermodynamic states are always in thermal equilibrium with each other. If two systems are in thermal equilibrium, then the third system will also be in thermal equilibrium. Yes, Vamsi, very good. D is correct. When two systems are in thermal equilibrium with a third system, then they are all in thermal equilibrium with each other. Okay? Chalo. Change in enthalpy in a closed system is equal to, यानी कि DH, change in enthalpy, is equals to heat transferred. If a reversible process takes place at what? Pressure, constant pressure, temperature, volume, internal energy. Yes, D is correct in the last question. What is correct here? It is true for constant. Constant what? It is valid for constant pressure. And du is equals to dq for constant volume. Yes or no? Yes or no? You should know this, guys. Okay. Internal energy associated with kinetic energy of molecules is. So internal energy that is associated with kinetic energy of molecules is nuclear energy, chemical energy, sensible energy, latent energy. I hope you all know that Joule's law tells you internal energy is a function of temperature. That means if change in internal energy is basically directly proportional to change in temperature. And whenever change in temperature you will observe, it will be a sensible energy or sensible heat. Sensible energy or sensible heat. In latent heat, there is no change in temperature. This is energy due to bonds, chemical bonds between molecules. Okay? Chalo. Which of the following represents the perpetual motion machine of first kind? Which of the following represents the perpetual motion machine of first kind? Perpetual motion machine of first kind. Engine with 100% thermal efficiency, a full reversible engine, transfer of heat energy from low temperature source to high temperature source, a machine that continuously creates its own energy. Very good. D is correct. This is PMM2. This is PMM2. This is Carnot engine, Carnot cycle. This is reverse Carnot or heat pump or refrigerator cycle basically. Okay, and this is your PMM1, where work is not equal to 0 but heat is equals to 0. So it is creating its own energy and giving you work output, which is not possible. Which equation is the correct representation for the steady flow energy equation? Steady flow energy equation. Which option is correct? In nozzle, Q is equals to 0, W is equals to 0, change in potential energy is equals to 0. So what do you get? What do you get? What do you get? Option A, H1. You can write M1 H1 plus V1 square by 2 is equals to M2 H2 plus V2 square by 2. Now because it is steady flow, so M1 is equals to M2 is equals to M. So you are going to get this is equals to this. So A option is correct. A option is correct. ठीक है, चलिए. What is the velocity of steam at exit? यानी कि you need to find out V2 in a nozzle which is perfectly insulated, Q is equals to 0 and produces no work and undergoes a drop means by H2 minus H1 is equals to minus 0.2. So H1 minus H2 is 0.2. Calculate the velocity. So if you use this equation, and as we know in a nozzle, V1 is much less than V2. So V1 can be neglected. So I have H1 is equals to H2 plus V2 square by 2. So V2 is equals, now if I need to write this in kilojoule, then I have 2000 here. Okay, so it will be 2000 H1 minus H2 this. So I can write it directly here. V2 is equals to under root 2000 H1 minus H2. So 2000 into 0.2 is equals to 400 is equals to 20. क्या है आंसर? What is the answer? 20. 20 is the answer. ठीक है? Got it? Yes? Yes. Chalo, next. Which gas can attain the highest efficiency for the same compression rise? For the same compression rise. Highest efficiency for same pressure rise. For same pressure rise, highest efficiency. So highest efficiency you are going to get. How you will get highest efficiency? By efficiency is equals to work output upon heat input. So if work output is max, if you increase work output, efficiency will increase. Now, how will you get work output? Work output can be, you can get work output by seeing the curve, okay? So, you see, here slope is 0, here slope is infinite. And this this quadrant will give you work output because it is expansion, okay? Now, yes, monatomic is correct, very good. So if the slope is high, now slope is increasing in this direction, okay? Slope is increasing in this direction. So as you can see, this will be your monoatomic gas. This will be your, what is the value of N for monoatomic gas? It is 1.67. 1.67. Okay. For same compression rise, it is saying, okay, for same compression rise, if you are saying compression, okay. So basically you need minimum work. You need minimum work. Yes. So basically we will see it here. 0 say infinite, and as you can see, if the value of N is maximum, the work will be maximum. We have already seen this, okay? If the value of N increases, work increases. So if the value of N is maximum, which is maximum for monoatomic gas, for diatomic it is 1.4, for triatomic it is 1.33. So as you can see here, you will get the maximum one is monoatomic. So you will get C as the option. C will give you maximum work. Output. Okay, chalo. Next, isothermal compression through most efficient but is not practical. We have seen already isothermal compression is the most efficient. Why? Because you need to give minimum work. Compression is this side, okay? PV diagram. So this is constant pressure, this is constant volume, this is isothermal, and this is adiabatic. Now in isothermal, we have to give minimum work. You see, this is minimum area, so minimum work we need to give. So isothermal compression is always most efficient because you have to give minimum work. But why we can't use it? Because isothermal process is done in a very, very slow manner, so that no friction will be there. If you move your piston faster, then friction will be there. Process cannot be isothermal. So you do isothermal process at infinitely slow speed, and that is not practical. That is not practical in actual systems. In actual applications, it is not practical, okay? So if you want isothermal, compressor has to run at very slow speed to achieve it, which is not practical, okay? Chalo. For a given system, if heat is added, heat is denoted by Q and work is denoted by W, then cyclic integral of this. So cyclic integral of dq minus dw will be what? Cyclic integral for closed system will be what? Quickly. C is 0. Yes. Why? Bhaiya, for closed system, we know that dq is equals to du plus dw. So dq minus dw is equals to du. Is equals to du. Okay, is equals to du. So I can write it as cyclic integral of du. And u is a property. U is a property. And change in property for a cycle is 0. Change in property for a cycle is 0. We know this, right? Yes or no? Change in property for a cycle is 0. Yes or no? Clear? Chalo. If they ask for a process, then what will be the integration of dq by w? For a process, it is for a cycle, okay? If they ask for a process, then what do we know? We know that dq is always greater than dw. This is your second law, okay? You have to give more heat. dq is always greater than dw, and therefore this integration will always be positive. This will always be positive. But for a process, it is for a process, not for a cycle. Chalo. So it is 0. A liquid of mass, we have liquid of mass 1.5 kg and specific heat 3 kilojoule per kg Kelvin is stirred, causing the temperature increase by 10 degrees Celsius. What is the work done for the process if the system is insulated? That means there is no heat transfer. So we know dq is equals to du plus dw. So now dq is equals to 0. So dw is equals to minus du. Okay, so minus mc delta t 1.5 into 3 into 10. Kitna hai answer? How much is the answer? What is the answer? Minus 45, Baba. Minus you forgot. Minus you forgot. You are doing stair work. Stair means you are giving work input. And if minus is given, then you have to take care of minus. If minus is not given anywhere, then 45 is correct. But because minus is given in the question, you have to write minus 45. Okay? Chalo. The heat interaction of the system is a function of temperature. So, heat is a function of temperature. Like this. If the system does work of this, yani ki dw by dt, yani kilojoule per Kelvin is given, 2 kilojoule per Kelvin. Find out internal energy per degree Celsius. This I need to find out. So I have the equation dq is equals to du plus dt. Let me differentiate it with respect to temperature. dq by dt is equals to du by dt plus dw by dt. Now I have to find this out. So if I differentiate this equation with respect to temperature, I will get 1 plus, sorry, du by dt plus 2. Kitna aa raha answer? Du by dt is equals to 1 minus 2, which is minus 1 kilojoule per Kelvin. Kilojoule per Kelvin. This is the answer. A. ठीक है? चलो, last 4 questions left. A gas is compressed frictionless from an initial state. So this is your initial volume and initial pressure P1 to a final state. This is your V2 and P2. There is a transfer of 40 kilojoule of heat from the gas. Yani ki dq is equals to minus 40 and a drop of 20 kilojoule in internal energy. Now if drop you are saying by du is what? Du is u2 minus u1. Now if they are saying drop is happening, that means it is minus 20. u2 minus u1 is minus 20. What is the initial state volume of the gas? Initial state volume of the gas. So very simple, by dq is equals to du plus dw. Now as you can say, P1 is equals to P2 is equals to 1 megapascal. So it is a constant volume process. It is a constant volume process. So I can write minus 40 is equals to minus 20 plus pressure V2 minus V1. Minus 40 minus 20 plus 1000 0.2 minus y. So you can calculate y. कितना आ रहा है y? How much is y? How much is y? आया? कितना आ रहा है? B is correct. B is correct. 0.22 meter cube. Very good. 0.22 meter cube. Got it? क्लियर है? चलिए, let's move ahead. Two gases X and Y having the same temperature. We have two gases. They both have same temperature, same pressure and same volume V. If the mixture has the volume V, mixture also has the volume V and the temperature T, then the pressure of the volume of the mixture. Pressure of the volume of the mixture. How to convert what, Baba? What do you want to convert? Chalo. So that means two gases are mixing. One, it has number of moles N, pressure P, volume V, temperature T, and another gas is also mixing. Number of moles Na, let us say, Nb, pressure, volume and temperature are same. So when they are mixed, it will come out as Nc, which is equals to Na plus Nb. Pressure I don't know, let us say P3. Volume is same, temperature is same. So I need to find out pressure. So P3, volume remains same. Volume, this and this is same. They have told us that, okay? Is equals to N3 RT. So I can write volume for P3 is equals to N3 RT by V. Now what is N3? N3 is equals to Na plus Nb. Okay. Now what is this? What is this? Na. So you can apply this here. So Na is equals to PV by RT. Nb is also same. NB is also same, pressure is same, volume is same, RT. So you can write 2 PV RT. You can substitute 2 PV RT into RT by V. What is the answer? P3 is equals to 2P. कितना आया? 2P. Okay. Got it? Chalo. So 2P is the answer. Second last question. A closed balloon containing, so I have a balloon that contains 10 kg of helium, receives 5 kilojoule per kg of heat. During this process, the volume of the balloon slowly increases to 0.2 at constant pressure of 100 kilopascal. I have to find out change in internal energy. Very simple question. dq is equals to du plus dw. I have to find out du, so it is dq plus dw. Mass into specific heat, not specific heat, but heat, it is kilojoule per kg, right? So I have to multiply it by mass. Pressure delta V. So it is 10, it is 5 plus 100 into 0.2. How much is the answer? 50. Okay, sorry. Just 1 second. It will be minus, okay? Minus 50 minus 20. How much is it? 30. Yes? आ रहा है नहीं? क्लियर है? चलो, let's come to the last question for today. The internal energy of a perfect gas depends on. Just now I told you in the class, internal energy is a function of what? Is a function of temperature only. Is a function of temperature only, according to Joule's law. So C option is correct. ठीक है? चलो, very well. So guys, if you have not joined the Telegram group, do join the Telegram group. I will share the PDF of this class as well in the Telegram group. Okay, and guys, already Vision 2025 and 26 batches are live. I have finished thermodynamics. Other batches are aligned. You can join new batches as well. So if you want any guidance for these batches, which is a very structured course, okay? You have live classes, recorded lectures, study material, practice quizzes, mock test, etc. So if you want any guidance, you can call this number to book 1-to-1 counseling session if you want to know any information about the course, okay? And also counseling form is there in the description box, so you can fill a counseling form as well. Very well. So also there is so much going on the app. Please download the app because it will help you remain updated. There are so many free sessions that we take on app as well. Okay. Chalo. Thank you very much, guys. So we can stop here and I will see you very soon I will see you tomorrow anyway. ठीक है?